Carbon fiber. An exceptionally rigid material known for its resistance to extreme pressure and physical impact. It's widely used in cars, motorcycles, aerospace, and more. But can it be used in speaker drivers? Let's find out. This material starts as a single thread, which is then woven through a complex knitting process. To achieve extreme rigidity, the woven structure is infused with a special resin. Today, many speaker drivers are made from carbon fiber. Beyond their stunning appearance, they also deliver impressive sound quality, and with a bit of creativity, you can even make one yourself at home. The final result will be a perfect blend of beauty and stiffness. This material can last up to 50 years. When multiple layers are combined, it forms an incredibly strong and massive structure. But is it possible to use this material in speaker drivers to extend the frequency response and achieve fewer peaks? Can we replace a paper cone with a carbon fiber structure? The answer is likely yes. In this video, we discussed that a good speaker cone needs to be lightweight, highly stiff, and have suitable damping to extend the frequency response and reduce unwanted peaks. Carbon fiber checks all these boxes, and its unique properties allow for the creation of beautiful, durable speakers with excellent sound quality. In the simulation software, we'll replace the paper cone material with carbon fiber. As shown, the paper cone naturally filters out high frequencies. To extend the frequency response, we need to change the material. Let's switch the diaphragm material to carbon fiber. While there are many types of carbon fiber with varying stiffness based on this table, we'll rely on the software's data. Keep in mind that Young's modulus measured in gigapascals or megapascals is an indicator of material stiffness. For a 0.4 mm thick diaphragm, the total weight is only 1.3 grams, meaning we have a rigid, lightweight material. Its damping properties are also sufficient to help reduce peaks in the frequency response. After changing the cone material, the response is clearly extended up to 10,000 Hz. Now, let's check a real 6.5-inch woofer. This example is only meant to demonstrate the driver's behavior, nothing more. The woofer offers an almost smooth and extended response, which is impressive for this type of driver. Its moving mass is around 18 grams, which is quite heavy and results in a low resonance frequency. This could be due to factors like the number of fiber layers, the amount of resin, and the specific fiber type used. However, this doesn't cause any significant negative impact on performance. Instead, the improved durability and extended frequency response should be our main focus. Of course, the weight reduction compared to a paper cone woofer isn't always drastic, but the increased stiffness and durability of carbon fiber still offer a noticeable advantage. A well-optimized carbon fiber cone can even be lighter than a paper one, while maintaining better structural integrity. Thanks for watching.